Hello everyone, welcome back to my channel. I hope you are doing extremely well. So today we are going to learn one of the most second question of dynamic programming series, which is nothing but fraud jump with k distance. So let's try to understand the question first. So a fraud wants to climb a staircase with n step given an integer array height where height I contains the height of the ith step and also k is given which like basically indicate that we can take maximum kth step at a time. To jump from the ith step to jth step, the fraud requires this absolute difference energy. The fraud can jump from ith step to any step in the range from I plus 1 to I plus k. So what we have to return the minimum amount of energy that required by the fraud to go from 0th step to n minus 1th step. So let's try to understand from one example. So this is the one example which is given here. Basically 10, 5, 20, 0, 15, right? And k is given 2. So this is the array. And we have to so this is the array, okay, and we are at here at the 0th step at this place, and let's try to understand with another example. So like we're at here, we're at this place, right? So from here we can take this is 2 step at a time, and then from here I will take this step. So let's assume that from here what would be the required energy is 10 minus 20 absolute, that would be 10 plus from here absolute is 20 minus 15, that would be 5. The total energy is 15, right? So the minimum required energy to reach the last stair is 15. This would be our answer. So how can we do with this? So like so definitely when we are at a place, okay, and we need to do a multiple we need to perform the multiple task, multiple operation at each, you can say in that, then in that case recursion would be the one of the choice that we can take. So let's try to understand. Let's try to build recursion tree from here, right? There would be let's assume that this is the array. This is the another example which I will take, and I will try to draw recursive tree diagram. From 0th we can either take 1 step, or we can take 2 step, or we can take 3rd step, right? Is it clear? Yes. So let's assume that at the 0th place the value is 15, right? So if I will take 1 step, so what would be the value? That would be nothing but 15 minus 4, the absolute, right? After that what would be the 11, right? That would be 11. So we got 11 here. We from 0th step to 1 step we require 11 energy, right? So from here, from 1 we can take either one step, means 1 plus 1 we can reach 2. Either we can take this one step, this is the 2 step. Either I can take two step, that would be I reach third index, or I can take 3 step at a time and I can reach the 4th index, right? So here from 2 I I can also, what would be the energy, what would be the required energy to reach at the 2th index? That would be 4 minus 1, that would be nothing but 3. So if I will be here, then I require 3 energy. Okay, from here I can go either 1 step, 2 step, or 3rd step, right? If I will take 1 step, then from 2 I can reach 3. If I will take 2 step, then from 2 I can reach the 4. If I will take 3rd step, then I can reach 5. That would be the index out of bound. So from here I will return 0, right? So from here 3, definitely, like if I will here and calculate from 2 to 3, I need 11 energy, right? Yes, sorry, from 2 to 3 I need 13 energy, right? So from 3 also, from 3rd index I can reach at the 4th place, 1 step. So if I will take the 2 step, then I can reach the definitely 5. If I will take the 3rd step, then I will reach the 6. These all are index out of bound. So from here I simply return 0, right? Yeah, I have reached at the 4. So from 3rd stair to 4th stair, how much energy I require? That is 1. So if I will add this all energy, okay, so from here I need definitely 11. From here to here I need a 3rd energy. From here to here I need 13. From here to here I need how much? 1 energy. So total what would be the energy? Total would be the if I will add all simply, then total would be the definitely be the C. So what is the approach, right? So see here, if I will add all this, then 13 plus 3 is 16 plus 1 17 plus 18 means 28 would be the energy. But see here, what we will do here. So basically from here, this is the 0. This is not possible. Okay, we cannot take this step. So from here, from 3rd to 4, we minimum we can have to spend 1 energy, right? So if we are at the 2nd place, if we are at the 2nd index, so there are 2 valid way. If I will take the 4 steps, so from 2 to 4, what would be the energy that I have to spend? That is 14, right? But see here, but if I will take 2 to 3 and then 3 to 4, so what would be the energy? 2 to 3 is 13 plus 1 14. So from here I have to spend 14. But here also if I will take 2 step, then here if I will take 2 step, then here also I need to spend 14 energy. So in both the cases the minimum would be 14. So from here I will simply return 14, right? So from here, if I will take 1 step, then it gives me the 14 minimum energy. But if I will take 2 step, so at the 3, right, at the 3rd place, see here I have already calculated here. So definitely this would gives me 1. From 3rd to 4th, definitely it would give me 1. So see what would be the minimum energy? 14 plus 1, right? 14 plus 11. 14 plus 11, that would be what? Definitely be 25, right? But if I will take here 1, from 1 to 3rd, right? Yeah, definitely if I will take 1 to 3rd, then it is need how much energy? Definitely 11 plus 1 12. So it is 12. So definitely 11 plus 12 would be what? Definitely 23. So 23 would be the minimum as compared to 25. So from here the minimum would be what? 23, right? And see, from 0th index, if I will take 1 step at a time, so it gives me 23 energy minimum, right? But if I will take 2 step at a time, so let's see. what would be the minimum. So from 2, like if I will take 2 step, okay, so 0 or like 0 to 2, what would be the like 13, definitely, sorry, 14. And if we are at the second step, so what would be the minimum? That would be the 14, right? So minimum would be the 14 because we have already calculated from here. So 14 plus 14 is 28, but minimum is 23, right? So yeah, let's see if we are at the third place. So from 0 to third, what would be the minimum? From 0 to third, what would be the minimum like energy? That is definitely be 1, because at the absolute difference between 15 minus 14 is 1. So from here it gives me 1, and if we are at the third place, so as we know that if we are at the third, that's the minimum energy that needs to reach the last stair is 1. 1 plus 1 is 2. So out of 20, out of 28 or 23 or 2, what would be the minimum? So minimum is 2, and 2 is our answer. Let's check. Yeah, this is the correct. So we can say that this is the 2 is our answer. So I'm sure that this recursive diagram helps you a lot to understand how can we do it, right? Let's try to write down a pseudocode, and definitely this pseudocode is not any language dependent, it's language independent. By understanding this code, you can write down your code by your own language, whatever in which you are comfortable, either C++, Java, Python. So let's try to understand. Let's try to write down function. I will here basically write int function, and definitely the array, and this is the definitely index. It represent where we are currently now, and k, right? What, let's understand. Yeah, what would be the base case would be there. Yeah, so definitely I will take one minimum integer minimum, and I would declare it. I will initialize it with the maximum value. If yeah, after that what I will do, I will simply execute a for loop. Step 1, then from where I will firstly simply I will check that if index plus step, if it is index out of bound, right? Yeah, if it is greater than definitely or equal to nums dot length, in that case what I will do, simply I'll just break down from this loop. If not, right, if not, then in that case what I will do, simply I will current value is that current energy definitely would be absolute difference between a nums index minus a nums index plus step. Right, slice the minimum. That would be math dot min. That would be what, either the minimum or the current energy. At the end, I will simply return the minimum. So yeah, I hope this code helps you a lot. Let's comes to the code editor. So at the first, what I will do, I will write one method that helps me to calculate minimum energy to reach the last stair. So yeah, public find energy g integer height then k and current stair. So yeah, after that I will declare simply minimum energy would be what integer max value. I will execute a for loop step 1. I will take till kth step and step plus plus. Every step I will before calculating I will check that is current step if is current step would be index out of bound or not. Current step is valid, means we can take or not. So I will check if current step plus step is equal to height dot length or it is greater than that. I will simply break. Right? Else, let's calculate the current energy equal to math dot absolute value difference height current stair minus heights current stair plus step. So then I will basically check either what would be the which one would be the minimum, and I will say assigning to the minimum energy dot mean energy current energy, and at the last I will simply return minimum energy. So if I will check here, I will from here basically then I will calculate, simply call that height and k and 0. I hope it to work. Let's try to run this code. Okay, wait, it is giving me the error check why it's giving me the because yeah. So actually yeah, it's my bad that I have forgotten to call this method. Yeah, and another thing is that I have to also write one base case where if the current stair is at the last step, definitely in that case we don't need to move. We don't need any energy. So in that case I will simply return 0. Right. If I try to run this code, it worked perfectly fine, but if I will try to submit this, so it gives me time limit exceed. Why? Let's try to understand. So here basically what we are doing at every step we are calling, okay, so at every index we are calling k time, right? So that the time complexity would be, so basically the time complexity would be definitely k power n, right? This is the time complexity of this code. And if I talk about the space complexity, so it would is order of n because at most due to recursion call. So how can we optimize this code? If we can see it carefully, so at every time there is some value which we have to recalculate it. See here, if I will see here 3, again it comes and we are again recalculating it. Same is like 4. There are 3 times, okay, 1 2, yeah. So it means that some value we are calculating, there is some duplication, means same value we are calculating again and again. So how, so we can definitely reduce it through memorization. So, and when it comes to memorization, so definitely DP, so dynamic programming comes in mind. So let's try to implement the dynamic programming here. So basically what we will do, firstly I will initialize the DP here, DP of length and see here like DP and what can we do here, basically yeah, okay, if we can see here, definitely if I will check, and here I will at the end I will basically initialize the at current state what would be the minimum required energy would be what this, I will initialize the DP. So yeah, before doing this I will check if current state we have calculated previously if yes, so let's check DP current state is not equal to -1. If it is true, so in that case what can we do, we just simply return the current state value. That's it. I hope that it's clear to you, and let's try to run this code. I'm sure that it will work perfectly fine. Okay, it's giving me the error. Let's wait. Yeah, let's see what is the, okay, yeah, it's not -1, it would be 0, right? Yeah, it's worked perfectly fine. Let's try to submit the code, and yes, it has submitted correctly. So if I will tell me about by applying the DP, what would be the like a time complexity is that so time complexity would be order of n, because at most we are calculating n number of step. Okay, we don't need to recalculate and we don't need to revisit the same step again and again. And if I talk about the space complexity, so this is order of n due to DP plus order of n because we are doing it through recursive call, right? So definitely this space complexity I can also optimize it through tabularization. So till now we learn about the DP of how can we do optimization. In the next video I will definitely tell you and share you how can we do the same thing by using a tabulation method. So till now, bye bye, take care. I hope you love this video. Thank you so much for watching the video.